the next one from 11th standard, unit and measurement. The topic is error. Okay, you know very well. Say for example, I have to measure the length of this pen. Okay, say for example 15 centimeter. Okay, but I measured as for example 14.8. Okay, so if you observe that here that error is that is a 0.2 centimeter. Okay, or otherwise suppose I measure as 15.2. So now also that difference, that is the error, that is also 0.2 centimeter. Okay, so actually the error is nothing but that there is a difference between that measured value and the actual value. That is error. Okay, so in that error, generally it is error. So that error, there are two types. Okay, that one is we called as that is a systematic error, and another one is the random error. Okay, so now we are going to discuss one by one in this session. Okay, with a small example. So please listen. See that. So error means that. So we have there is a difference between the error is nothing but there is a difference between that is a measured value minus actual value. So it's nothing but there is error. So that only we mention as in the other way, that is any uncertainty measurement of that any physical quantities. Okay, so what there are that uncertainty. Okay, if something is definite means there is no error. Okay, say for example here that how many pen is here. Okay, here how many pen. So totally 3 pen. Okay, here there is no error. Okay, suppose if you observe that here in this pen, let's take one pen. Here, how many atoms are there? Okay, here some chance to make error. Okay, how many molecules are there? Some chance to error. Okay, so whether the surface is what is that exactly polished or not? Okay, so microscopically it is not. It is not like what is that? Polished. Okay, so like that if you observe I'll give one small example. Say for example the number of pupils in a room. Okay, so for example now in the hall. Okay, so in the hall, maybe your classroom. So in the classroom every day they are writing that number of roles, then number of students on roll. Okay, number of students present, number of students absent, like that. So it is like a definite one. Okay, then every day afternoon they are asking the campus report, how many students are there. Okay, in the whole campus how many days are present. Okay, because that is some certain value. Okay, so that means here there is no uncertainty. Okay, so it is everything is a fixed value only will come. Okay, 2 means 2, 4 members means 4 members, 6 members means 6 members. Okay, totally 50 members is there, 40 or 48 members are present, 2 members are absent. So we can get some clear value. Okay, so in that kind of cases we can say no uncertainty. Okay, so then see the next one. So if you observe the next example, you can understand. Yes, it's chance to we can get some chance to get the error like that. See the number of atoms in the room. So let us imagine in the room how many atoms are there. We can't say accurately. Okay, approximately we can see. So I'll count here. At the time here, the atoms value will be changed. Okay, so we can say that number of atoms in the room. This is like an approximate value only. So in this kind of example, maybe some chances to introduce the error. Okay, so that kind of error, there generally there are two types. There is the classifications of error. So that first one, that is a systematic error. Okay, that is error. Okay, in that also some systematic is there. Okay, say for example, see that first one. First I'll give that one is the systematic error. So the systematic error means these errors tend to sift the result in one direction. So if this kind of error executed, then after the error, what is that? Some result to come, uh, that result continuously changes in only one direction. Okay, so that error continuously in one direction. Okay, so why? So what are the causes for that? So that only I explained here. So in the three way I explained. Okay, so if systematic error happens means what are due to what? Okay, so this first one. So the first one is like instrumental error. Okay, instrumental error. Say for example, let us take vernier caliper or screw gauge. So this kind of experiment is there. Okay, so you can measure that is the thickness of the thin strip, or otherwise what is the diameter of the spherical bar something. So so many years the same apparatus we are using. Okay, suppose so due to the different kinds of students handle that apparatus, so maybe some errors is there. Okay, so that is like instrument error. Okay, so suppose if you know that how to rectify the error means no problem, or otherwise we don't know how to rectify the error, simply we take the reading means that error will continue in all the reading. So that means will changes in one direction. Maybe it is plus value or minus value, it will be changing continuously is going. So please listen. So we can say that is instrumental error. Okay, see that say for example in the meter scale. Okay, say for example, it is like let us imagine it is like a meter scale. Okay, so if you observe that in the meter scale, let us imagine it is very new. It is very new. Okay, now only I buy this scale. Okay, so here that every reading is accurately we can see that. Okay, suppose then after 10 years, then after 15 years, okay, again you are taking that same scale maybe at the edge, okay, maybe at the edges or in between or somewhere, okay, that reading is not clear. So that only we can say that the meter scale it is worn off at the end. Okay, எங்கேயோ கொஞ்சம் அப்படியே தேஞ்சு போன மாதிரி இருக்கும். Okay, the reading is not clear. So even in that kind of situation we are taking reading, so that is some instrumental error will come. Okay, due to the instrumental error we will take the reading wrongly. Okay. So that is one example. Then another one, see that there is an imperfection in experiment, imperfection in the experiment technique or procedure. Um, say for example, here I mentioned one example. If you go to that hospital clinic, suppose if you feel some what is it feverish. Okay, so at the time that nurse they are checking before consulting the doctor. First, they are checking whether you have what is it fever or not. So by using thermometer, they are checking. Okay, but actually, when they are using the thermometer, if they want to somewhat accurate reading means, so they must use in the mouth only. Okay, but instead of mouth, they are using in the armpit only. Okay, the thermometer they are using in the armpit. But actually, in the orbit temperature, okay, it is a lesser temperature comparing with the mouth temperature. Okay, so this is one of the error. Okay, it is one of the wrong method to examine the what is that temperature of the human body. But even they are following the method. So that only they say that imperfection in this experiment technique or otherwise the procedure. Okay, some wrong procedure they follow. But even it is continue. Okay, so this kind of error to execute that systematically. Okay, then another one like that personal error. So personal error it is the man-made error, sure, absolutely. So that it is due to our mistake only. We take the reading wrongly. Say for example, let's take thermometer. So thermometer here the reading is mentioned. Okay, so he shows some reading here. But I measure wrongly from here, or I measure wrongly from here. Okay, so just you have to observe that point exactly on the line. So your what is that? Your eyesight should be on the line. Okay, but instead of that, they are using that under the line or upper the line than something. Okay, so that is like what is that? Personal error or man-made error. Okay, so they don't know how to take the reading. Okay, in that Ohm's law apparatus, ammeter is there, voltmeter is there. Okay, um, some members, if they put the A means they know ammeter, B means they know voltmeter. Suppose it is what is it due to some scratch, so they didn't mention that A value and B value. So unknowingly they interchange that voltmeter ammeter. So that is also man-made error. No? Okay, so we can say this kind of so many examples man-made error. Okay, because we measured wrongly. That is the meaning. Okay, right. So that instrument error, that is imperfection, that is a irregular procedure, and the personal error. So this kind of causes to produce the systematic error. Okay, even we are follow this kind of things. Okay, right. But now you should know. Okay, no, if you made this kind of error means this is related with the systematic error. So now you should know. Okay, like that. The next one, that is a random error. Okay, random error best example. Now you have to take the reading. Now you have to take the reading. What is that? Current reading, EB bill reading. Okay, so if you observe that nowadays that digital, what is that? Kilowatt. Okay, that is kilowatt meter. Okay, so it shows the reading. That submeter. It shows the reading. Okay, so if you observe that meter, so for example, it shows that even the voltage level also to 24.8. Just you have measured in that moment. Then after very next time and after few seconds, if you observe means again that voltage is changed as to 28 voltage. Like that it is changed. Then after sometimes if you measure, that is it is changed as to 27.2 voltage like that. Because there is some fluctuation. There is some fluctuation because it is that wire, it is coming from very large distance, traveling the large distance. Okay, so along its path, there's so many disturbances are there. It will cross the different climate and different temperature. So due to that, its resistance will be changed. So that so many causes. Okay, due to that so many causes, so its value it will change randomly.